Okay, so in this video we're going to find the area under the parabola 1 minus x squared that I kind of already have graphed here. It's not perfect, but it doesn't matter. I want to have some space to draw the rectangles. So we're going to try to find the area under this curve, approximating using eight rectangles and using the right endpoints. So what we're trying to do is use we know that the sum is going to be approximately the area is going to be approximately the sum of the areas of rectangles. So this is, I'm going to go from I equals 1 to 8 of the area of these rectangles, or i's, that I'm going to call. Who are those rectangles? Well, I'm going to cut this into 4 pieces, like that. And then I'm going to keep going to cut it into 8 pieces, so it doesn't look exactly correct, but it doesn't matter. Just to give us an idea of what's happening. And we want to do these rectangles, so I'm going to do these straight. They're not evenly spaced, but it doesn't matter. I mean, they are evenly spaced, just in my picture they're not. Okay. So what I'm doing is I want to find, so this is going to be x1, x2, and so on. This is x8. This should be evenly spaced. Okay, it doesn't look like that, but just a sketch of what's going on. And then what I want to do is I want to grab this, and really, since this is, I'm going to write here, copy my formula on the right, sorry. So this is going to be the area of the rectangles. So the area of the rectangles is really just, what I'm doing is find the right endpoint. Means that at this rectangle, I'm going to use this side as my height. I'm going to use that one. So you see that for each of these rectangles, in this case, because my curve is concave down, each of these rectangles is going to be under the curve. So I'm going to end up with a underestimate, right? This last rectangle is 0. So there's no sum there. I'm going to end up with an underestimate of this. So who's the area of the first rectangle? Well, this base times the height, right? And the height is this value over here. So x1 is really 1/8, right? If I do it 8 evenly rectangles, the formula for the width is b minus a over n, where b is, in this case, this is your b, and the 0 is your a. So in this case, my b minus a over n is just 1 minus 0, so 1, n is 8, so it's 1/8. So this is what we call the delta x. So I'm going to write here that this is, the delta x is the base of the rectangles, and the height is whatever the function is at xi, right? And then I add all these from 1 to 8, and I get approximately the sum. So why is it this? Because this is the height when I plug in x1. This is too thick. When I plug in x1, I get this as a height, right? And the height is exactly 1/8. So when I do x2, when I plug in x2, I'm going to get this height, and that is that's going to be f of x2. So this is changing. Okay, so then what I need to do now, once we get that, sorry, and I keep going until I'm going to have it for each one of these points, right? A value at the f function gives me those different heights. But the base are all the same. The bases, I mean, it doesn't look like that, but these bases are all equal to 1/8 if I did it evenly. Since I'm writing using the right endpoints, then it is exactly 1/8, 2/8, and 3/8, and so on. So if I do this, my next step would be, if I continue, I'm finding the f function was 1 minus x squared. I have it up here. So my function is, I need to evaluate how high are these rectangles. So it's just 1 minus xi. Sorry, I'm going to, instead of xi, it's a good point to write here that just xi is really just I over 8, right? The x1 is 1/8, x2 is 2/8, and so forth. So instead of writing 1 minus xi squared, I'm going to write 1 minus I over 8 squared. So that's my function. And my delta x is 1/8, so I'm going to write it like that, and I still have the 1/8 over here. That 1/8 is this delta x that's constant for every rectangle. So the first thing I can do is I can, I'm going to copy this because I want to show you a little property that we can do here, is that this 1/8 is constant. So what I'm doing here, I'm adding these quantities times 1/8 when I is 1. Then I'm going to add this when I is 2 times 1/8. Then again when it's 3 and times 1/8. So this 1/8 is a common factor for each one of those. So this 1/8 I can move it to the front like that. It really is a constant. It's kind of factoring really on steroids, just factoring over these 8 terms. Okay. And so then I don't need this parentheses. If I do that, I really do not need this parentheses. Because the only term that's squared, well, I kind of do because they're inside this sum, so I'll leave it to parentheses if you want. But what this means is I have the 1/8 outside, and I have two terms adding. I'm adding from I equals 1 to 8 a 1, and I'm adding, well, in this case subtracting, when I equals 1 to 8 the I squared over 64, correct? Because I squared over 8 quantity squared becomes this. This 1/8 is multiplying both of them, so I should have it like that. I can separate this sum like these two, or this sum that was here has 2 terms. I can break it up like the sum of these terms, the sum of these terms, and then they're joined by this minus sign in the middle. Okay, so when we get to here is, there's 2 things here that's important to realize. This first term here, I'm really just adding a 1 when I is 1. The next one would be adding another 1 when I is 2, another 1 when I is 3. So it's adding 1 plus 1 plus 1 plus 1 8 times. So this guy becomes an 8. And the 1/8 is outside, okay? So I'm going to leave it like that. Okay, so that's just because I'm adding 1 plus 1 plus 1 8 times. Now on this side, I have something else I can do. So I'm going to remove this 64 is constant, so I can bring it outside like we did before. And I am adding the I squareds. Okay, so when I get to this point, it looks like, okay, we're stuck. We can probably find out what is I squares and do these together. We don't have to if we know this formula. So I'm going to assume we have this formula that we know that if you're adding I equals 1 up to n of the squares, there's a formula that can be proved that it's just n times 2n plus 1, n times n plus 1 times the 2n plus 1, all that divided by 6. That's exactly what we have. So if you assume that we know this formula, if we have that tool, then we just use it right here. This is exactly what we have when the n is 8, right? So that's all I need to do. So I get 1/8 times 8 minus, let me distribute that 8. That 1/8 in here, it looks nice if I do 1/8 times 8 is a 1. Then I have 1 over 8 times 64 is 512. And then I use the formula that I have over here. Okay, so that formula is going to become, plugging it in right here, it is n, which is 8, times n plus 1, which is 9, times 2n plus 1, so n is 8, so it's 16 plus 1, it's 17, and all that divided by 6. So you put that in your calculator. It's not that hard to get, and we get 1 minus, this is 204, actually divided by 6, over 212, and you can do that in your calculator, and I get 0.6015625. So that's my approximation for this sum. Okay. So I know this is an underestimate because I did it from the right, and in this case the curves are from the right. They get under the curve. Okay. Okay, now I want to do the same thing, but now from the left. We have a lot of work doing here, so I'm gonna really just tell you that this is the same problem with a subtle difference. If I do it from the left, I'm gonna copy everything and see. I'm gonna copy this. Oops, sorry. I'm gonna copy the picture and just show you that it is the same thing, right? It is. What I'm going to do is paste here that picture, and so something is wrong. It's not the same, guys. Of course, it's not the same rectangles, but I can use a lot of what I use here, because now what I'm going to do is, instead of using this side, I'm going to try to erase these guys. Make the thinner. I'm going to try to erase these guys. Because if I use the left endpoints, then they're going to be this rectangles. So now they're going to be overestimates. Okay, so this last one that was 0 before, it's not going to be, right? The points, notice that the dots that I had here, these are the same. The heights are the same, only that they're used on as heights for the other rectangles. So R1, in the past, the height was 1/8 plugging it in, but now for the R1, it's 1, right, when you plug it in, because I'm using the 0 as my input. So it's a little bit, it's the same idea. It's going to do it it's not going to take us that much, because when I write this down, all I'm going to do is notice that, well, the area is approximately the same thing. It's going to be, I'm going to jump to the sum of I equals, now look, pay attention to what's going to happen here. If I look at it carefully, I am going to do 1 minus xi squared, but my xi's are starting not from 0, sorry, not from 1, they're starting from 0 now. Because the first one I'm plugging in is this one, which is x0. This is x1, x2, and my first height is this. I'm using the 0 as my input, right? So I start with 0, and I stop at 7. For my last rectangle, this is x7, right? So there are still 8 terms adding, but it starts from 0. The base is 1/8, so I can leave it like that. So I wrote the xi here, but I can do this like, take the 1/8 out like before, and I'm going to put from I equals 0 up to 7 of 1 minus, and this is the same as before, xi is I squared over 64, correct? Like that. So now when you break it up like I had before, I get the 1/8 times sum of I equals 0 up to 7 minus, sorry, of a 1 minus sum from I equals 0 up to 7. I can put the 64 outside, and I squared. So it's pretty much the same thing as I had before, only that now the first term is the same. Here from 0 to 7, I'm still adding 8 times a 1. So this is also an 8. Okay, now over here, this is what makes it a little bit different, because this term is, so at this point in the other one, I distributed the 8. So let me do the same thing. So I'm going to get, this is an 8 with that 1/8 is a 1. And this gives me the 1 over 412. But I'm adding, here it's the same formula, but now my n is 7. Because the first term, when I equals 0, is just a 0, right? So it already stopping at 7. So the formula was n times n plus 1 times 2n plus 1 divided by 6. So that inserted here becomes 7 times 8 times 2 times 7 is 14 plus 1, 15 divided by 6. So that's what the sum becomes on this side. So now what this becomes is, oh, sorry, this is not over 64 is outside. So if I do this carefully, it becomes 140, I believe. So it's 140 over 512. And this gives me 0.7 2656, I believe.